In this video, we're going to try to define the Cartesian product of two sets. Let A and B be any two sets. Okay? And we define a set as a collection of objects. But for us, we think of A as some set of numbers. Okay? To define the Cartesian product, which we denote by A cross B, as the set of ordered pairs where A is in A and B is in B. Okay, we will see later that we can extend this definition to more than two sets. Okay, for instance, if we have A is the set that has two elements, 1, 2, and B the set that has 1, 2, and 3, we can find A cross B. Okay, so it's going to be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay, if we count the number of elements in this set, this new set A cross B, we're gonna see that the cardinality of A cross B, we're gonna denote by cardinality of A cross B, it's gonna be 6. Okay, so here we have 6 elements in this set A cross B. Okay, we can do this one even graphically. We can see that. So our set A is gonna be on the x-axis, 1, 2, it has 2 elements, and the other set has 3 elements. So we can represent these elements by dots. Okay, so here this is 1, 1, this is 1, 2, this is 1, 3, this is 2, 1, 2, 2, 2, 3. And we see that we have 6 elements. Okay, we can also denote the cardinality or the number of elements in the set by this symbol. Okay, so it's the number of elements in the set. Okay, our aim in here is to find the cardinality of A cross B. Okay, to do that, we see that if we assume that A has n element and B has b elements, so we're gonna see that the number of elements in A cross B is gonna be n times B. Okay, to see that graphically, so we assume that A has n element. Let's denote them by A1 and AN, and B has b elements. Let's denote them by B1 up to BP. Okay, we get all the elements by counting the number of pairs. Okay, so to find the number of elements, we're gonna count in this way. We're gonna fix the AIs and let the BJs change. So the cardinality of A cross B is gonna be the sum of the AI times B, where I is going from 1 to n. Okay, so here let's say A1, but A1 cross B is just B. Okay, the number is B because in this case we have only A1 and BJ, where J is changing between 1 and P. Okay, and in this case the cardinality here for this one here, the cardinality of A1 times cross B is P. The same thing, we can say that the cardinality of AI cross B is just P. So here, when we have this one here, so basically we're gonna add p n times, and this gives us n times p, and therefore this means that the cardinality of A cross P is just the cardinality of A times the cardinality of P, okay, which is equal to NP. We can extend this definition to more than one set. Let's assume that we have A1, A2, and AK sets. So K sets in this case. We define the cross product of this set in the following manner. So here, let's say A1 some I, or A1 some I1, A2 some I2, and A sub, let's say K, I, K. So each element belongs to the set A sub I, okay? And in this case, we see that we extended the definition, okay? For instance, if we have the sets A, B, C, so the Cartesian product in this case is going to be just the number of elements in order A, B, C, where A is in A, B is in B, and C is in C. Okay? It's ordered elements where each one belongs to the set that's coming from. Okay? And this and in general, if we have these sets, so they are finite. That's what we need in this case. If they are finite, then the cardinality of A cross B cross C is just going to be the cardinality of A times the cardinality of B times the cardinality of C. And if we have K sets, A1 times A2 times K, or let's say cross, okay? So the cardinality here is just the product of AI, where I is going from 1 to K. So let's use this symbol here for the cardinality. Okay? And in this way, we extend the Cartesian product to more than one set. We'll see its application when we are dealing with probabilities and in sample spaces. Thank you.